Hello, I'm Michael.
I'm JP.
Today we're doing lab 4, which is the cam and crankshaft position sensor. We are doing the camshaft. We have today a 2017 Subaru WRX with a 2.0 leader.
The camshaft position sensor tracks the position of the camshaft, helps the ECU manage timing and fuel injection and ignition. If faulty, it could cause rough idling, poor acceleration, or difficulty starting. On this engine, there are 4 camshaft position sensors. One of the first locations is up here up top. There's a connector behind this wiring harness, and the sensor is bolted in with this 10mm right here. Directly underneath, with my laser pointed on it, you can see there's the second one. On this side, that's the third one. Again, 10mm bolted in right here, connectors right there. And underneath is probably the hardest one to get to. I got my laser on it, but it's bolted in down there.
So with the sensors, we have 3 wires on all 3 of them. We have 2 shared wires, which is a red and a blue wire. You can see there. The red is the signal, 5-volt reference, sorry. The blue is the ground, and then each one has its own individual color wire in the middle. This one is the green-white, and that one is the return. And then just to confirm, this is the wiring diagram. We're pinned into the green-white, and then we have all the other sensors here. You have the common red, and then the common light blue with white.
Alright, so right now we're back probed into the signal wire. This is a digital signal, so we are getting a reading in hertz. That's our frequency. If we were to switch it to voltage, we're gonna only get a constant steady about 4.6 volts. That's why we decided to switch it to our frequency signal. Right now, we're having a reading of about 18 hertz and dropping. The reason why that's dropping is as the engine is almost at operating temperature, it's pretty warmed up now. Our cam signal is not as frequent as if RPM increased, but I can show you right now as I step on the throttle what would happen to our signal if we were to raise the RPM. Now, I'm not sure what reading you saw there, but it should have been roughly for the first blip about anywhere between 40, 50, maybe 60 hertz, and then increased when I really pressed on it the second time. And that shows how our frequency signal from that camshaft position sensor increases as RPM also increases.
So we just hooked up the scan tool. This is the time that I was off, and then this is when it just turned on the vehicle, so the sensor turned on, and we're just slowly seeing it creep over. So we're going to cause a fault. What we're going to do is we're going to short the signal wire to ground. And we can do it anywhere, touch it there. We also just can do it to the battery, negative. And then we're going to go see what type of faults there are. So we're going to go to the scan tool, we're going to read fault codes, it's going to communicate. We got P0340, which is just the bank 1 or signal sensor. We're back here on the WRX. We are using the P code for our CMP. We have a back probe on the signal wire with a ground. And then we have the signal right here. So what we think is it's a 5-volt signal right now, and then we have divots within the reluctant wheel, and it's 3 divots, space, 3 divots, space.
Alright, here we have pulled up on the computer on all data our reference oscilloscope readings. Right here is the one that we measured. There are 4 for the 4 camshafts and the 4 camshaft position sensors. This is the right-hand side intake side, which is the one that we back probed into, and it matches our pico reading, which is 3 divots for our 3 off times, and then it goes back to 5 volts. The purpose of the crankshaft position sensor is to measure the exact position of the engine in a given moment of time. That could be finding top dead center of a certain piston and where all pistons are at. It also measures the engine's rotational speed, the RPM. Without that, the engine may not start, the engine may stall, the engine may idle roughly.
So this is the wiring diagram for the Colorado. We have 3 wires for the crank position sensor. We got green, violet, blue, and then black. Is right there, you can see it's plugged in. But right now we have it probed for the signal wire, and then we have it grounded just over here by the exhaust.
Okay, so right now we have the engine running. We are back probed into the signal wire. And right now that it's running, we're at about 0.7, 0.8-ish hertz as the RPMs are dropping. So there's a signal drop. But then when we rev it, go ahead. You can see the signal increases as RPMs increase. Okay, so right now I got the live data. This is the RPM from the crankshaft position sensor right next to the kilohertz reading, and they're roughly matched, pretty close. So as the engine speed goes up, so does the signal. It's gonna go up to 2500 here in a second. And this is pretty close to 25. I mean, it's at 24, 2.4 kilohertz. But they're very close in range. Not bad. All right, right now we got the pico scope hooked up to the crankshaft position sensor. We're opened up on our program here, and as you can see, we have a 20 millisecond division, and our trigger there isn't any. We're only showing our A channel. As you can see, there's a, if I stop it actually, you can see where the missing teeth are at. So we have a reading if we individually counted it. I'm not sure how many that would be. That's the amount of teeth we have, and then those missing ones show the PCM, at what position the engine is at, all the pistons are at.